Welcome back, students. In today's video, I want to provide an overview of what the electromagnetic spectrum is, and then to understand what wave speed is and what frequency is. Firstly, I just want to overview the electromagnetic spectrum, so I'm going to draw that out right now for you. Okay, so here I've drawn out my electromagnetic spectrum. I've already shown this in the previous video. I just want to summarize it in this video. What this is a spectrum that we can use to identify different parts of light based on their frequency and their wavelength. We know that light is an electromagnetic wave, and like any other wave, they have some frequency or wavelength. And whenever they have big wavelengths and low frequencies, those light waves are radio waves. And then as the frequencies get bigger and the wavelengths get smaller, it goes from radio to micro to infrared waves to visible light, which is going to encompass everything that we can see. So all the colors of the rainbow, from red, orange, yellow, green, blue, indigo to violet. After visible light comes the ultraviolet light, X-rays, and then gamma rays. Okay, so on the right side of this spectrum, gamma rays have the lowest wavelength and the highest frequency of all of these different types of light. On the opposite end of the spectrum, radio waves have the largest wavelength and the smallest frequency. What do I mean whenever I talk about these different wavelengths and frequencies? So we know wavelength is the distance of one wave, which we can measure from crest to crest or trough to trough. So we can see here on the left side of the spectrum, from crest to crest, there's a larger distance than there is on the right side, where it's almost even harder to see. So large wavelengths, small wavelengths. Waves also have some sort of speed associated with their motion, right, as they move. In the case of light, all of these types of light waves travel at the speed of light. The wave speed for all of these types of waves is the speed of light. We use a lowercase c to notate speed of light. The speed of light is approximately 3 times 10 to the 8 power meters per second. In 1 second, light can travel 300 million meters. Okay, so now we've covered wave speed and wavelength. Now I want to talk about what frequency is. In a previous video, I mentioned that wave speed or wave velocity is equal to wavelength times frequency. Okay, so this is the equation to show that velocity equals wavelength times frequency. Because we know that the speed or the velocity of light is always just going to be the speed of light, we know that v is going to be constant in this equation. Because we know that velocity is constant, we also know that the product of wavelength and frequency is also constant. It's always going to be equaling up to the speed of light whenever I multiply wavelength times frequency. So as wavelength goes up, frequency has to go down to accommodate that. So when wavelength goes up, frequency goes down, or vice versa. Whenever wavelength goes down, frequency has to go up. Just to recap what frequency is, frequency describes how many times a wave cycles in 1 second. On the left side of the spectrum here, these waves are going to cycle less frequently than the waves on the right side, which move through the cycle of going up and down and then repeating that process much faster than on the left side. But that's going to be all for today's video. Thank you guys. See you next time.